Section 6.2a, Law of Cosines. Formula for Law of Cosines is given there. Remember when we talked about Law of Sines, we talked about finding the smallest angle first whenever we can in Law of Sines. For Law of Cosines, it is exactly the opposite. We want to find the largest angle first when using Law of Cosines. You may not always have that choice. If you do have the choice, though, always find the largest angle first. That will always identify whether you have an obtuse angle in your triangle or not, which Law of Sines will not. With Law of Cosines, just like what we talked about with our area formula involving the sine function in section 6.1b, there are really three different forms of the law of cosines. The thing that you have to be careful of, remember A, B, and C lowercase letters represent side measures. The uppercase letters represent angle measures. Whatever side you have by itself on this side of the equal sign is the angle that you must have represented on the other side of the equal sign. So in other words, if I rewrite law of cosines as b squared, now we're going to have a squared plus c squared minus 2ac, and it's going to be now the cosine of b. Likewise, if I isolate c squared, now it's going to be a squared plus b squared minus 2ab times the cosine of a. So it's not really three different versions that you need to learn. You just need to remember that whatever side we have isolated here is also the angle that must be represented on the other side. Solve the triangle. Remember, when we solve a triangle, we want to list all three angles and all three sides. So in this case, we know we need to find angle A, we need to find angle B, and we need to find angle C. If you have a choice, using law of sines is much easier. Why do we have law of cosines? Because we don't always know one complete ratio that must be known in order to use law of sines. Remember, if we do not know an angle and a side opposite that angle, we can't use law of sines. So in this case, all we know is the three sides. There would be no other way to solve here other than using law of cosines. So we're going to go to law of cosines. We know in this triangle from the side measures that angle B is going to be the biggest angle because side B is the biggest side. So we want to use the form, remember, law of cosines, find the biggest angle first. So I'm going to have 19 squared equals 8 squared plus 14 squared minus 2 times 8 times 14 times the cosine of B. Now, when you go to plug this into your calculator, a lot of people are going to make calculator errors, so make sure you're following along and you are plugging this in your calculator as you go. 19 squared. 19 squared is equal to 19 squared is equal to 361. 8 squared plus 14 squared is equal to 260. And now this is all multiplication, so I need to take 2 times 8 times 14, and that's the coefficient then on cosine of B. You cannot subtract these two numbers. We're solving for cosine of B, so my next step is to subtract 260. We get 101 equals negative 224 times the cosine of B. Now divide by negative 224. Take the inverse cosine or arc cosine of that value, and you're going to get angle B to be 116.801 degrees. Next, go to law of sines. Law of sines, remember we want to find the smallest angle first. Not necessary that we do it in this case because we've already identified that there is one obtuse angle. We know all the others now need to be acute, but get used to doing that so you're used to following those rules every single time in case we didn't or weren't able to find the biggest angle first here. So next we would want to solve for angle A. So the sine of A over 8 equals, the only ratio we know now is for B, sine of 116.801 over 19. Multiply by 8, take the inverse sine. We get angle A to be 22.075. And now we need to find the third angle. Remember, you should always find the third angle by subtracting from 180, so you guarantee yourself that all three angles add up to 180. We get 41.124 degrees. There's the three missing angles for that triangle. Number 2. Once again, we do not have one complete ratio. I know an angle this time, but I don't know the side across from that angle, so we cannot use law of sines. We again need to go to law of cosines. The angle that we know is 120 degrees, so that tells us the side that we need to isolate with our formula is the side opposite that angle, which is a squared, equals b squared plus c squared minus 2bc cosine 120. Plug all that into your calculator. Should be able to plug it in just like you see it. Make sure this is all multiplication, so you put that in parentheses back behind. So in your calculator, 3 squared plus 10 squared minus, put all of that in parentheses. You should get 139. Take the square root, and side A is 11.790. We also need to find angle B and angle C. We now can go to law of sines. So you should never have to use law of cosines more than once in any problem. So it's a little bit more of a cumbersome formula to use, but you should only have to use it one time. We're going to find angle B next. It's the smallest, and with law of sines, we always want to find the smallest angle if possible. So we have sine of B over 3 equals the sine of 120 over 11.790. Multiply by 3, take the inverse sine, we get 12.73 degrees. Third angle we always find by subtracting from 180, so 180 minus 120 minus 12.73 is 47.27 degrees. Herons formula is another special formula we have for finding the area of a triangle. It's used to find the area of a triangle when we know all three side lengths. Here's the formula, where S in the formula represents the sum of the three sides divided by 2. A, B, and C are the three measures of the angles. So the first thing we need to do is add up the three sides, divide by 2. That's our value of S. Then simply plug into that formula, and you have the area. So in this case, we know 3 side measures. First thing we need to do, find the sum of those 3. Divide by 2. Our value of S is going to be 91.8. Once you have S, go directly to your formula. Area equals the square root of S times S minus A times S minus B times S minus C. You should be able to plug all that into your calculator just like you see it on there. Plug it into your calculator the same way, using parentheses the same way. And you get 1,354.583 feet squared.